All right, ready? Let's put our phones away. Accuracy is defined as how close the measured value is to the true value. Smallest increment would be the precision. How close the measured values are to each other, right? The difference between two measured values, that would be tolerance, maybe closer, but this is what you were supposed to select there. A is how close the measured value is to the true value. An object weight on a balance is determined to be 0.05 grams. The precision is 0.01 grams. It's D, right? That second decimal is what we're after, so the answer is D. The wingspan of a female red-tailed hog being monitored to collect migration data is 130. What's the precision and uncertainty of this measurement? Right, you should know that precision is 1 centimeter, so the uncertainty is 0.5 centimeters. So the measurement with its uncertainty, right, is, why does it say? It's supposed to be that one. I don't know why it's, I guess because this device could be to the nearest, but I didn't teach it that way. So A is it. How about you just rule out the other ones, right? And then you're left with A. Next, you have Jeanette measured the length of a piece of copper pipe using tape measure marked in 0.1 centimeter increments. That always trumps everything else, even the measurement. What's the most precise measurement she can record, right? And the answer is this, because the precision of this thing is the nearest 10th of a centimeter, and so C is the answer there. Okay, it can't get, like, this is what your target is, but it can't read that. It has to stop at the 1 decimal point. Relay team, right? You're practicing, and there's your 4 runs, right? 1, 2, 3, 4 runs. They all have the same precision and uncertainty. So it says if the times are added, how long will it take, including the uncertainty, meaning the combined uncertainty. So what you can do here is say that the precision is, if you look at seconds, right? These are your seconds. Precision is 1 second. So the uncertainty is 0.5 of a second. Okay? And because they all have the same uncertainty, the combined uncertainty would be 4 times 0.5 of a second, which is 2 seconds, right? So if you figured out that the combined uncertainty is 2 seconds, you get 1 mark there. I would say if you got the precision, if you got to this part here, you get 1 if you get the 0.5. If you come up with a combined uncertainty, that will be another mark. And then you just need to add all of those times together, right? If you add all of these together, you end up with 7613. Actually, no, this is what you get, right? If you add the minutes and the seconds, you end up with 7573, right? And we know that 73 seconds is more than a minute, right? So you're going to take 60 away from here and give it another minute there. So 76 minutes, 13 seconds. Sorry, just like that. Plus or minus 2 seconds. So if you get 75, 73, I would not give you the combined times mark. I would only give you the combined times if you actually took away the 60 seconds from this, added a minute to your total time, and then are left with the 13 seconds remaining. Yeah. The whole thing? I would say yes, then it's okay. Yeah. You went from minutes to hours? No, I would say it has to be like this or all seconds. All right, because then you're taking away precision. Um, so yeah, 1 minute for coming up with an uncertainty of 1, 1 mark for combined uncertainty, and then obviously this gets you a mark if you get that right. Doctor measures a dose of 2.00 mLs. What's the precision uncertainty of this measurement? The precision is right 0.01 of a milliliter. Uncertainty is half of that. So you get 1 mark for the precision, 1 mark for the uncertainty. That should have been a home run, in my opinion, at this point. Which of the following is most precise? And this is the winner, right? Provided they're all in millimeters, right? It's the one that has the most decimals that is going to be the most precise. If this had been like meters, centimeters, millimeters, then obviously millimeters would have won because it's the smallest, right? Okay, so this page is 10, right? Because if it doesn't say what it's worth, like multiple choice was worth 1, so we're out of 10 on this page. The back side. What's the length of this bar, including the uncertainty? So allow me to do this first. On the side here, I will note that the precision is what? It's 1 millimeter, or it's 0.1 centimeters. It's up to you. The uncertainty is therefore 0.5 millimeters. So if you come up with this on the side somewhere, I would give you 1 already. 1 mark. So now measuring this, we get, I get 62 millimeters, plus or minus 0.5 of a millimeter. Or if you want it in centimeters, it's 6.2 centimeters plus or minus 0.05 of a centimeter. Either one of these is fine. So you would get a mark for stating the measurement with its uncertainty. Which of the following describes the concept of tolerance? The length of a gutter must be a minimum of 12 feet. A drilled hole has to be big enough to fit, but small enough that the dowel will not fall out. That right now is the closest. Combined weight, that's not really it. The average weight is also not it. This is the best definition of tolerance, right? It has to be big enough to fit, but small enough that will not fall out. Okay? 10, the nominal is defined as the target value of measurement, C. That's what the nominal is. Which of the following is another way of expressing the manufacturing tolerance? And here's where Friday, like I did touch on this on Thursday, but Friday is where really this would have come in handy. Okay, so what you need to do, and this is where you pay attention, right? Every single time, you should be able to get the max, min, tolerance, and nominal out of any. There's 4 ways of stating tolerance, right? So the max is 0.7650. The min is 0.7550. The tolerance is you subtracting these two, right? Max minus min, right? So your tolerance is 0.01 of an inch. Okay, we're talking inch, 2 marks are inches. And the nominal, do you remember if it's like this, you have to find the middle. You have to add them and divide it by 2. And so the nominal would be 0.7600 inches. So once you take this, you have this inventory, you can state it in any form you want, right? Any of the other forms that you want. So another way of expressing this would have been This is not it. It's this one right here. You can, right? This is telling you that the lowest is that and the highest is the tolerance. And you should be able to identify this on your study sheet, that this is the format, right? That would match that. Because if you think about it, you take the min, right? Minus 0 plus the tolerance, right? So A is your right answer there. A is the answer. This couldn't have been, why? Because the nominal is this, okay? This could not have been it because the nominal is this, right? And just on its own, it just can't be. It has to be something following it, right? So like, watch this one is also another lesson from Friday. So given the tolerance of the pipe as being this, okay? State the tolerance in 3 other forms before I do anything, okay? You should recognize this form. This is a nominal plus or minus half of the tolerance. That should be on your study sheet. You should recognize that format. So you can get the max, the min, the tolerance, and the nominal just by looking at it. Okay? So the nominal is 64.5 centimeters. It's always the big number in front. The tolerance is what's inside, 0.9 centimeters. The min is taking this and then subtracting half of that. Let's do that here. Where's my calculator? So find half of 0.9. 0.9 divided by 2. You can write that down, 0.45, right? So to get the max, you're going to go 64.5, sorry, 64.5 plus 0.45. So that's 64.95. And to get the min, you would just get the 64.5 and subtract half of the tolerance. So that's 64.05. And once you have this inventory on the side, you can state it in any one of the other forms, right? And I already gave you what they're supposed to look like. So if you want max min, just copy these down. 64.95 centimeters. You have to have the units there every time, right? So this would be one format. The next one calls for min in front minus 0 plus whatever the tolerance is, 0.9 centimeters. So this is the next one. The next one calls for the max first. Oh, we should always add units, okay? Just make sure you will never lose marks if you add units. Okay, plus 0 minus the tolerance, which is 0.9 centimeters, right? So there you have. So from this, I first gathered this information, and then I branched out to my other formats. So for you to get the marks, you have to have them exactly like that, and you get 1 mark for each correct format. You essentially wouldn't be getting any marks for getting that inventory on the side, but you do get marks for this. Yeah.
What 0.45
Tolerance. Yeah. So if I would say minus 1 for sure, and then I would give you follow through marks for the rest. So wherever there's tolerance, you put 0.45. So I would, out of the total, if everything else is the same, I would just take off 1 full mark for getting that wrong. Because this has to be 0.9, right? That's our tolerance. So this backside is worth 7. 7 marks for the backside. So 10 and 7, that's 17. Name and last name. And get 7, 10. What's that? Which part? Okay. So get ready for another one. Okay, so call then. Okay. All right.